Hello student, welcome to my class. In today's video, I'll teach you another name reaction, that is Zelinsky reaction, HVZ. This is very special reaction, and this reaction is used, this reaction is performed on carboxylic acid. Basically it is the halogenation of carboxylic reaction. When the carboxylic acid having alpha hydrogen is treated with red phosphorus, then alpha hydrogen is replaced by halogen, then this is called HVZ. Now come to the main reaction of Volhard-Zelinsky reaction. If we take carboxylic acid that containing alpha hydrogen, this is the alpha hydrogen, treated with red phosphorus, halogen and water. Red phosphorus is taken is in a small amount, and halogen is either we take chlorine or bromine, and we will get alpha halo carboxylic acid. Alpha halo carboxylic acid. This is the HVZ reaction when carboxylic acid having alpha hydrogen is treated with halogen in the presence of red phosphorus, then alpha hydrogen is replaced by halogen and we will get alpha halo carboxylic acid. This is the HVZ reaction. Now come to mechanism of HVZ. It occurs in 3 steps. First step is formation of when phosphorus react with halogen and form pH3. If we balance this reaction, then we will take 2 molecules of phosphorus and 3 molecules of X2, and here 2 pH3. Phosphorus trihalide. First step is the formation of phosphorus trihalide. Now this phosphorus trihalide react with this carboxylic acid. Second step is the reaction of phosphorus trihalide with this carboxylic acid. Either we take phosphorus trihalide like PCl3 or PCl5 or SOCl2. It is also used for the formation of acyl chloride from acid. As in the case of Rosenman reduction. Now, if this acid react with pH3, then the OH is completely replaced by halogen and we will get Now this OH is completely replaced by halogen. This is keto form. Here the very important point is tautomerization. Tautomerization is nothing, only the transfer of proton. And this keto form will convert into enol form. How it will convert? The electronegativity of chlorine and oxygen is very high. It withdraws electron toward itself from the carbon. So the carbon is electron deficient center. It is electron deficient center, so this hydrogen sacrifices its electron and leave the group in the form of H+, and the bond between carbon and hydrogen is shifted between these two carbon, and the oxygen completely withdraw electron toward itself, and this keto form will convert into enol form. Now here O minus, then this H plus bind with this O minus and form RCH double bond COH X. This is enol form. This is keto and this is enol. Here tautomerization. Tautomerization takes place. Tautomerization is nothing, only the transfer of proton. Here the proton transferred from this carbon to this oxygen. Keto form and enol form. Now we have X2. If X2 came in the scene, then there is no electronegativity difference, but due to the presence of this electron cloud, there is a creation of partial negative and partial positive. Partial positive. Now the bond, the bond between these two carbon completely shifted to this halogen, and this halogen take This is enol form. If the X2 came in the scene, then there is no electronegativity difference, there is no positive and negative charge, but due to this electron cloud, there is the creation of partial positive and partial negative charge. Now this is electron deficient side, and here is a electron cloud. So this pi bond shifted between the carbon and halogen, and this halogen take electron and leave the group in the form of X minus, and here form R CH X C O H and X. Now the loss of this carbon happened because the bond between these two carbon completely shifted. So loss, that's why there is a positive charge. Now this oxygen has lone pair, so lone pair completely shifted between the carbon and oxygen and reduced the positive charge. If the lone pair shifted, then there is a loss of oxygen, so there is a positive charge on this oxygen, and this hydrogen leave the group in the form of H plus and donates its electron to this carbon and form RCH X. Now C double bond O and X. Now we have water in the medium. So if water, we can write water like this. If the oxygen of water is also electron rich center, it also search for the site which are electron deficient. Now this carbon is electron deficient site because the atom attached to this carbon are oxygen and halogen, both are high electronegative atom. So this oxygen attack on this carbon and bond completely shifted to this oxygen, and the molecule is formed here positive charge and now halogen, but again the negative charge here shifted and this halogen leave the group. Now when this halogen leave the group, because halogens are very good leaving group, and form Now oxygen is high electronegative atom, but it has positive charge on it, so it's not possible for oxygen to carry positive charge on it. That's why this hydrogen leave the group in the form of H plus and donates its electron to this oxygen and form. Now this is halogenated acid. This is very special reaction and this is very important reaction from the examination point of view, and HVZ is the halogenation of acid. Here we take red phosphorus in small amount. We take red phosphorus in a small amount, and here halogen, either we take chlorine or bromine. Fluorine and iodine are not acceptable, only chlorine and bromine. And now this is alpha. This is the functional group, and the carbon attached to this functional group is alpha carbon. So alpha halo, that halogen group is attached to alpha carbon. That's why it is called alpha halo. This compound having carboxylic group. That's why it is called alpha halo carboxylic acid. Now this is the complete Volhard-Zelinsky reaction, HVZ reaction. Now I hope I made it clear to you. That's all. Thank you.